Hey, thank you for being here on my space and welcome to my poster. Today I'm very glad to talk about my project entitled Study and Evaluation of Thin Films by synthesized by chemical deposition for the design of a mirror for an emitter layer. I'm Jesus Octavio Sigala Valdez, a student of a PhD degree in the Universidad Autónoma de Zacatecas. We use the CEDAR methodology to synthesize semiconductor materials. In this project, we work to synthesize a multi-layer structure based on zinc sulfate and cadmium sulfate to construct an emitter layer. These two materials are well studied in the literature and have the properties to be named as a good emitter layer. First of all, a bandgap in the order of 3.4 and 2.5 electron volts for the zinc sulfate and cadmium sulfate respectively. A optical transmission above the 20%, and good electrical properties. In this project, we use a homemade equipment present in the figure 1 to synthesize this multi-layer structure. As an experimental details, we show you in the figure 2 a schematic diagram of the Sealer process. Basically, the Sealer methodology is the successive ionic layer absorption and reaction. We can see the 4 steps involved in this methodology. First, the absorption, then a rinsing, third, a reaction, and finally, second rinsing. With this, we can achieve different thickness in the films and control the crystal structure of the materials. We can see also in the table the different concentration we use to achieve the 3 thin films we use. One is tin oxide, the second one is zinc sulfate, and the third one is the cadmium sulfate. And we can see in the figure 3 the different thin films we synthesize. As a question, if we combine the thin films, we can achieve the multi-layer structure we are working on. As a result, we characterize the films chemical, morphological, optical, and crystallographically. Using XRD, Raman spectra, UV-Vis spectra, and SEN image. All of these to secure that, first of all, we have the compounds that we want to, and without the presence of subproducts, and how we can synthesize these ones. First of all, the XRD, we can see here the different diffractograms. First of all, for the thin film separately, and finally for the multi-layer structure. For all of these thin films, we can compare it with the literature and have all the diffraction planes that are for the materials. So we are secure that the materials are in the thin films. Also, we can achieve a tetragonal crystal structure for the tin oxide, a cubic phase for the cadmium sulfate and zinc sulfate, and finally, with the multi-layer structure, polycrystalline nature or behavior. Consequently, we can observe in the figure 6 the same image for the coating synthesized. We can observe in the image of the zinc sulfate some cracks. These cracks synthesized are a very common problem that is a future work of optimization for being used as an optoelectrical device. Secondly, we can observe the optical transmission. This optical transmission is above the 20%, something good for being used as a window layer. We can observe all the signals for the compounds synthesized, and we can achieve a good optical response. Finally, we can see here the Raman spectra for the multi-layer structure synthesized, and all the patterns, the Raman patterns for the compounds alone. We can observe the characteristic longitudinal phonemes for the zinc and cadmium, and we can achieve that chemically is not subproducts in the thin films. Finally, the conclusion of this work is that multi-layer films can be obtained using a microcontroller sealer unit, showing a uniform substrate coverage and a low number of imperfections. Also, sealer is a suitable method for the deposition of a good quality multi-layer films, and we are working to publish this information and accordingly use it as an emitter layer. Thank you for being here. To remind you, we are working in the Universidad Autónoma de Zacatecas in the renovation lab of semiconductors. Thank you again for being here, and good day.